Here we're solving a rational inequality that has a fraction in it, of course. That's what's making it rational, and it's an inequality because it has an inequality sign instead of an equal sign. This problem is x plus 6 over x plus 2 is less than or equal to 0. We'll do the 8-step process for solving rational inequalities. Step 1, we make sure everything is on the left side and the right side is 0. Well, that one's already done. So let's go to step 2. Step 2 is the important step. That's why we put a starburst around it. That's where we're supposed to factor the top and the bottom. Well, we can't really factor these, so the top is the entire factor and the bottom is the entire factor. So we have our fraction less than or equal to 0. What does it mean to be less than or equal to 0? Well, basically it means that the fraction that we have here is going to be negative, and we need to remember that. Let's go to step 3, where we take the factors on the top and each of the factors on the bottom, set them equal to 0, and solve for the numbers. These are x values we'll be using to partition a number line. Step 4, 5, and 6 we do together. We write the fraction in its factored form, x plus 6 over x plus 2. And we're going to take a number line. These are x values. We're going to bust up the number line using the critical numbers we found in step 3. That's the number -6 and -2. And then we're going to consider the fraction in each of these regions. What we're going to do in each region is choose a value of x in that region, plug that value of x into the fraction, and figure out what the sign of each of the factors is. And then finally, we're going to write the sign of the entire fraction. Now for the first region, we just need to choose an x value to the left of -6. Well, let's see. That's a number x that's smaller than -6. To make it easy, in order to find the sign, let's just choose, let's say x equals -100, and let that be x, and see what we get for the sign on the top and the sign on the bottom. When x is -100, the top is -100 plus 6, which is a negative number. The bottom is -100 plus 2, which is a negative number, and a negative divided by a negative is a positive fraction. Now, in the next region, we choose a value between -6 and -2, any value between -6 and -2. Let's say -3. X is -3. Now plug that into the top of the fraction. We get -3 plus 6 gives me a positive result. Plug it into the bottom of the fraction. -3 plus 2 gives me a negative result. A positive divided by a negative is a negative. And finally, in the last region, I choose an x value that's to the right of -2. In other words, it's greater than -2. Any value I can choose here. I'll say, to make it easy, that x equals 0, let's say. 0 comes after -2, so I'll just choose 0 because it's easy to work with. When x is 0, the top is 0 plus 6, which is positive, and the bottom is 0 plus 2, which is positive, and a positive time over a positive is equal to a positive. So you see, for all x values to the left of -6, the entire fraction is going to be positive. For x values between -6 and -2, the entire fraction will be negative. And then for x values to the right of -2, the entire fraction will be positive. So now I'm ready to go to the important step 7, which takes me back to step 2. Back there in step 2, where the starburst was, we saw that the fraction is equal to a negative number. That's the only values that we're interested in, the values of x that make the fraction negative. That means we're only interested in x values between -6 and -2 on the number line. So I've shaded all the x values between -6 and -2, but I've done nothing to the endpoints at -6 and -2 because I don't know what to do with those yet. That's step 8. Step 8 says the original inequality had an equal portion in it. It was less than or equal to. That implies that we're going to include endpoints, only the endpoints that do not make the bottom of the fraction 0. Well, the bottom of the fraction was x plus 2, so the value of x that makes the bottom 0 would be -2. That means we're going to include all the endpoints but exclude x equals -2. Okay, so I'm going to go back up to the graph, and I'm going to put boxy brackets on the endpoints except not on -2. Round bracket on -2, boxy bracket on -6. Now my conclusion is that the solution to this inequality is the shaded region, boxy bracket from -6 to the larger value -2 with an open bracket.